Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss new chapter. I am going to discuss, that is the 6th chapter, General Principle and Processes of Isolation of Elements. General Principles and Processes of Isolation of Elements, that I am going to start now. A few elements like carbon, sulfur, gold, and noble gases occur in free state, while other in combined forms in the earth crust. The extraction and isolation of an element from its combined form involves various principles of chemistry. A particular element may occur in a variety of compounds. The process of metallurgy and isolation should be such that it is chemically feasible and chemically viable. Still, some general principles are common to all the extraction processes of metals. For obtaining a particular metal, first we look for minerals, which are naturally occurring chemical substances in the earth crust obtainable by mining. Now question is asked, what is the minerals? Okay, then minerals are naturally occurring chemically. Minerals are naturally occurring chemical substances in the earth crust obtainable by mining. Okay, this is the definition of minerals. Minerals are naturally occurring chemical substances in the earth crust obtainable by mining. Out of many minerals in which a metal may be found, only a few are viable to be used as a source of that metal. Such minerals are known as ores. Now again question is asked, what is the ores? Now you remember that out of many minerals in which a metal may be found, okay, only a few are viable to be used as sources of that metal. Okay, such minerals are known as ores. Means ores are coming from minerals. Okay, such minerals are known as ores. Again you listen, out of many minerals out of many minerals in which a metal may be found, only a few are viable to be used as source of that metal. Such minerals are known as ores. Means from ores comes from minerals. Means minerals, from the minerals you will get ores. Okay. Other things I want to tell you, that rarely an ore contains only a desired substance. It is usually contaminated with earthy or undesirable materials known as gangue. Again question is asked. Okay, all this in this chapter many questions you will ask, will be asked in examination. Many questions, small questions are there. You should know. Gangue question is asked, what is the gangue? Okay. Then here you can say iron ore contains only a very rare, very less, you can say rarely, you can tell, rarely an ore contains only a desirable substances. It is usually contaminated with earthy or undesired materials known as gangue. Gangue means earthy, earthly or undesired, you can say materials present in ores, that is called gangue. Okay. The extraction and isolation of metals from ores involve mainly, you can say, three processes are there. Many processes are there, but main three are there. First, concentration of the ore. Okay. Second, isolation of metal from the concentrated ore. And third is that purification of the metal. These are the major steps. First major steps, how will you get, you can say, metal from the minerals. From the minerals you will get ore. From the ore you will get metal. Then what are the steps? Then first step is concentration of the ores. Second, isolation of metal from its concentrated ore. And third, purification of the metal. The entire, in this chapter I am talking about, the here in this chapter you will study all details, how metallurgy is done, how we will get metal from its ores, all details you will study. Okay, many processes are there. Then the entire scientific and technological, you can say, process used for isolation of metal from the ore, or ores, is known as metallurgy. Okay. Then metallurgy means what? From the this metallurgy you will get metal. You will get metal from ores. Then this study, entire, you can say, this scientific and technological study is known as metallurgy. Okay. Now I will go in details. Here this first I will discuss about the concentration of metals. Concentration of metal is very, very important. From the minerals you will get ores. Then from the ores you require metal. Then this is done by, first step is concentration. What I am telling you, all these steps are in general, not particular. Okay, particular is different, but is in general, common, you can say, steps are there. That in many, you can say, metallurgical process, you have to follow these common steps. Correct? It will vary individually also, it will vary metal to metal, but in general I am talking about that general steps. Then first general steps are concentration of metals. Elements vary in abundance, you know. Among metals, aluminum is the most abundant metal. Okay. It is the third most abundant element. in earth crust. Its percentage is 8.3% approximately by weight. It is a major compound of many igneous minerals, including mica and clay. In mica and clay, you will find aluminum. Many gemstones are impure forms of aluminum oxide, Al2O3. Gems you might have seen, gemstone. Okay, in the ring you have seen people will be wearing all these things, metal, that is a stone, gemstone, and generally they are impure form of aluminum oxide. Aluminum is found in mica and clays, don't forget. Many gemstones are you can say impure forms of aluminum oxide, and the impurities range from chromium to cobalt. Here in this gemstone, chromium will be as impurities, and if chromium is if in aluminum oxide suppose chromium is present as impurities, then that is called actually ruby stone, RUBY. We might have heard the name. If chromium is present as impurities, then it is known as ruby. It is used for the sunlight, sun stone. For the sun planet, this stone is used. And this, if cobalt is present as impurities in aluminum oxide, if cobalt is present as impurities, then it is known as sapphire, SAPHIRE, sapphire, SAPPHIRE, sapphire. Okay. Iron is the second most abundant element. Second most. Third one I told you aluminum. Second one is iron. Iron is the second most abundant metal in the earth crust. Okay. It forms a variety of compounds, and their various uses make it very important element. It is one of the essential element in biological systems as well. Okay. Now, principal ores of aluminum, iron, copper, and zinc. Now I will tell you. Okay. Principal ores. What are the ores of these elements? These elements means aluminum, iron, copper, and zinc. These are very important elements. That's why I will tell actually many things you have to study, but these common things first I am telling you. Aluminum, iron, copper, and zinc. These four are common. Then what are their ores? Main ores I am telling you. For aluminum, bauxite is common ore. Question is asked. Okay, all you have to remember, and you should listen carefully. All questions are asked. Not only in the same examination, but in many examinations, all these questions, all whatever I am telling you, 100% these questions are already asked. Then first ore, this things, ore of aluminum question is asked. Its ore is, main ore is bauxite. And what is actually composition? Then its composition is ALOX, OH whole 3. Okay, ALOX. X means maybe 1, 2, 3 like that. Okay. Actually O number ALOX OH whole 3, then here X means maybe X value will be, I can say, sometimes less than 1. X value will be, means X is in the middle of 0 and 1. 0 is less than X. Okay, means I am talking about this oxygen. Oxygen its value will be maybe less than 1. Okay, then OH whole 3 I told you, but exact is 3.2x, 3.2x, where x may be less than 1. Now second ore I am talking about, that is the kaolinite. Okay, this is a form of clay. It is a form of clay, kaolinite. Kaolinite, kaolinite is a form of clay. And what is its formula? Then Al2OH whole 4, Si2O3, Al2OH whole 4, Si2O3. Okay, and what was for bauxite? Then for bauxite ALOX OH whole 3.2x, where x is less than 1. Now next I am talking about iron. Then it's actually here iron has 4 major ores. Then first one ore is magnesite. This magnetite. First ore you tell this hematite. Hematite is common. After that magnetite. Then first is magnetite, and its formula is Fe2O3. Fe2O3, hematite. Okay. Second is magnetite. This is the Fe3O4. Fe3O4. Here Fe3O4 means it is a mixture of FeO, ferrous oxide plus ferric oxide, means Fe2O3. Okay, it is a mixture of FeO plus Fe2O3. That's why now if you will add both FeO plus Fe2O3, then you will get Fe3O4. After adding Fe3O4, it is called magnetite. Then now third is siderite. Third ore of iron is siderite. That is a carbonate, actually, carbonate of iron. Carbonate of iron means FeCO3. And one more important ore of iron is iron pyrite. Pyrite means sulfide. Okay, don't forget. Wherever this pyrite will come, it means you are talking about the sulfur compound. Then iron pyrites, FeS2. Then this I have told about the iron. Aluminum and iron I told you. Two more I will tell you. Copper. First, now third is the copper. Then copper again has 4, you can say, major ores. 4. Then first is copper pyrite. Then again here pyrite's term is coming. It means sulfur is there. Then CuFeS2. CuFeS2. Means here with copper iron pyrite is present. FeS2 is present here. Hence its a chemical formula is there, composition is there, CuFeS2. And second one, malachite. Okay. Then it is actually carbonate of copper. Carbonate and hydroxide of copper, you can tell, both are there. Okay, carbonate and hydroxide of copper in a combined way. It is called malachite. Sometimes malachite green. Its composition is CuCO3, CuOH whole 2. CuCO3, CuOH whole 2 means carbonate and hydroxide both. Now third ore of copper is cuprite. What is its formula? Oxide of copper. Oxide of copper is called cuprite. Cu2O. Okay. Then this I told about the third ores. What is the fourth ores? Then this will be copper glance. Sulfide of copper is called copper glance. Okay. Then here Cu2S. Actually both. Cuprite was Cu2O. Then oxygen, you know that it is a 2 negative. Then for the 2 negative, 2 positive should be there to neutralize. Then both copper Cu2O means both copper is in plus state, cuprous. Okay, plus 2 is called cupric, and 1 plus is called us, cuprous. Less is called us, more is called ic. Fe2 plus, Fe3 plus, then more is called ic, less is called us, ferrous, ferric. Fe2 plus and Fe3 plus, then more is 3 plus, then ferric, less is 2 plus, then us, ferrous. Like here, copper exists in 1 plus and 2 plus, Cu1 plus, Cu2 plus. Then Cu1 plus is called cuprous and 2 plus is called cupric because it is more. Then now here this cuprite I told you Cu2O and copper glance, that is the Cu2S. Means here again copper is in plus form. 2 copper is in plus, sulfur is in 2 minus. Now I am coming for zinc, ZINC. Zinc is also very important. Then now first 3 ores are there. Zinc has 3 main ores. First, zinc blende, BLENDE. Zinc blende, or also called sphalerite. Okay, don't forget, sphalerite or zinc blende, both are same. Then zinc blende is called ZnS. ZnS is called zinc blende. Okay, it is composition ZnS. Zinc blende also called sphalerite. Okay, or sphalerite also you can tell, sphalerite. And second is calamine. Second ore of zinc is calamine, means carbonate of zinc. Carbonate of zinc is called calamine, ZnCO3. And zincsite is ZnO. ZnO is called zincsite. Okay. Then I have told about the ores of aluminum, iron, copper, zinc. Because main metals are these only. Others are also there, but in a common way these metals are common. Okay, aluminum, iron, copper, zinc, I told this ores and composition. Okay, for the purpose of extraction, bauxite is chosen for alumina. Okay, for extraction of aluminum, bauxite is chosen. Okay, for aluminum. For iron, usually the oxide of ores which are abundant and do not produce polluting agents like sulfur dioxide. Okay, generally sulfur dioxide is producing polluting agent. Then they will select such type of ore which will not produce polluting gases. Okay, for the purpose of extraction, bauxite is chosen for aluminum. For iron, usually the oxide ore is chosen, which are abundant. Okay, hematite, the magnesite and hematite, it is found in abundant hematite, Fe2O3. Then for iron, this hematite or magnetite is chosen or used because it will not produce polluting gases like sulfur dioxide. For copper and zinc, any of the what ores I told you is used. Okay, and this copper and zinc I told you, for copper and zinc any of the ores be used depending upon availability and other relevant factors. Okay, before proceeding for concentration, ores are graded and crushed to reasonable size. Okay, because now we are knowing about the ores. Then for concentration purpose, before this proceeding, before proceeding for metallurgy, then first step you have to do concentration. Then for concentration, ores are graded and crushed, means it is made in powdered form. It is crushed to reasonable size because there will be a big size. Then you have to crush it in a small pieces. Correct? Then these are the, you can say, first step, concentration. Then for concentration, ores are graded and crushed to reasonable size. Okay. A removal of unwanted materials, as for example sand, clay, etc. from the ores is known as concentration, dressing or benefaction. Three terms I told you. All three terms are sometimes asked in examination. Removal of unwanted material, as for example sand, clay, these are present as a gangue, correct? Then removal of unwanted materials, as for example sand, clays from the ores is known as concentration, dressing and benefaction. It involves several steps and selection of these steps depends on these differences in physical properties of the compounds of metal present and that of gangue. What type of metal is there, what type of gangues are there, accordingly steps, you can say this several steps, which step has to follow, that depends upon the gangue and which type of metal you are handling. Okay, then steps and selection of these concentration steps. Okay, it's a concentration of ores I am talking about, that it involves several steps, and selection of these steps depends on the differences in physical properties of the compound of metal present and that of gangue. The type of metal, the availability, facilities, and the environmental factors are also taken into consideration. Okay. Now, today is the first day of this chapter. I am stopping only here. Next class, I will discuss different processes like hydraulic washing, because concentration you have to do, concentration of ores. For this purpose, many processes are there. Then, example I am telling you, like hydraulic washing, okay, magnetic separation, froth flotation, like that way, froth flotation process. Many processes are there. Then one by one I will discuss, okay, in the next class. Thank you.